Hello everyone, it's December the 10th. Alright, let's do this. We're getting closer and closer to our goal. Count covered buildings. You're given a positive integer n representing n by n city. You're also given a 2D grid buildings where buildings I denote a unique building located at coordinates x and y. A building x and y. Okay, x and y, it's like a cell, right? A building is covered if there is at least one building in all four directions. Return the number of covered buildings. It's like the game Go. Okay. All buildings unique. This is actually a little bit more, I'd say, deceptive. So let's do this. N equal to 5, right? So basically we have a 5 by 5 grid. So go 1, 2, 3, 4. 1, 2, 3, 4. So building 1, 0, 1, 2, 3. So I have a building here. 1, 3. Hold on. Is 0 indexed or 1 indexed? Alright, I think it's... So basically we have 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So 1, wait, this is x-axis. What? Oh man, I have to do this conversion. So x is 1, y is 3. X is 3. Alright, so we have to do this type of conversion. That just feels stupid to me. So if we do this, right? So this is x, which is the index of j. So we have to swap the two and then minus 1. Yeah, so okay, anyway, so 3 and 2, 3 and 3, 3 and 5, and 5 and 3, 5 and 3. Okay, yeah, that makes sense. All right, so basically I want to know, given if I go just row by row, like I have this one, I want to know if there's anything above me. We can keep count of how many above you. As long as there's one, right? As long as there is one, then it will work. So we shall do, and n is what? N is 10 to the 5th, so n is 10 to the 5th. Okay, n is 10 to the 5th, so maybe not. Maybe not. So what we want to know is on a certain thing, how many there are. So in this case, on 3, right? So we have rows and columns. Okay, so we have rows. Okay, on rows, on the second row we have at position 3. Okay, on the third row we have position 1, 3, 5, and on the fifth row we have position 3. And on columns, on the first column, we have position 3. On the third column, we have position 2, 3, 5. And on the fifth column, we have position 3. All right, so this is what we have, which we can get directly from the buildings. Now, for each one, let's say I have 1, 3. Right? 1, 3 come out. I'm on row. It's actually column 1, okay, column 1 and row 3. So I look at a column 1. So column 1, row 3. So if you do yours, if you binary search, it has to be in the middle, right? And then this is not a good one. So now we have column 3, row 2, right? Column 3, row 2, binary search, you are the front. So that's not a good one. 3, 3, column 3, row 3, you are in the middle. So you just need to compare to the min and max, right? Just min and max. You don't even need a binary search, just min and max. And then column 3, yeah, that's a good one. And then we do 3, 5. 3, yeah, that's not a good one. We do 5, 3, that's not a good one. So yeah, so basically for each one, I just want to know the min and max for this row and the min and max for this column. It says, as long as the building covers there's at least one building in all 4 directions. Okay. I think we shall be able to get this done fairly fast. Just get the min max for each row and each column. Then I don't even need to use n. Do I even need to use n? Suspicious, because I'm not using n, so I'm not sure if that is going to be an issue. We'll see. So this is a 3, 5, 3, 1. We'll find the min max boundaries. Not my min max row column for each column rows, right? Let's call it x and y. So x is column, y is row. So x, y for each row and column. Then for each building, we check, right, whether its x and y are within the min max of its corresponding column, row and column. All right, so what do we need? And we have the values can go all the way to 10 to the 5th. So you want to do a map, you want to do an array of array. Yeah, let's just do map. It's okay. Unordered map int. What do we do here? Vector int. So we say rows, okay, and then we'll do columns, okay, and then we say for. We'll have to go through this twice, right? For const auto b of buildings, right? X go to b0, y go to b1. So x is the column, right? X is the column. So rows, how do I you can make this decision to get 4 maps or just 2 maps. I think 2 maps is good. So rows, then when we do it, it has to be, you have to compare, right? You have to compare. But if it's 2, then you always just, but then you have to swap them. That's okay. That's okay. So this is the column, right? X is going to be the column. Then we say if rows dot contains X. No, columns dot contain. If a column doesn't contain X, column X shall equal to 0, 0. Not necessarily. We want it to be min max, right? So the value is min max. So if it's going to be min, so this has to be n. Max is 0. Actually, we should say n plus 1, right? This is the main. This is the main. This is the max. Okay, and then we say columns x 0 shall equal to min columns x 0 and in that case, why don't you just use a pair, right? I think a pair will be easier. And you can always rewrite it, right? And then we say column x equal to this, and then this is not. So we say the first is going to be min, and then the first y, and columns x dot second max columns x dot second y. Actually, we shouldn't do this. We shall say dot at x, right? Dot at x. This is the same dot at x dot at x. Okay, so this is to handle the columns, and then if rows that contains y, rows y are equal to same thing, min max. So we can copy this. So columns will be rows, right? And then all the x will be y. And all the y is going to be x. Okay, so that's the first round. So after the first round, now we can say int res equal to 0. And we go through this again. Const auto b of buildings. Int x is b0, y is b1. And then we can say if x is larger than rows dot at y dot first, and x is smaller than rows dot at y dot second, and y is larger than columns dot at x dot first, and y is smaller than columns dot at x dot second, right? If that's the case, rest plus plus, and then at the end we'll return the result. Okay, let's run through this on these examples. Okay, pass the examples. Not too bad. I think, is there a faster way to do this? It's a tutorial. Simulation. Max row. This might actually be faster, honestly. Like, this might actually be faster than using a map. Okay, that will be it. I will see you guys tomorrow. Adios.